Hi everyone, I'm Adrian Cockroft. It's great to see everybody here at AWS Palo Alto in our wonderful new building. We moved in here late last year. It's got this lovely atrium. We've had a couple of meetups here. I'm really enjoying using the space. And thank you everybody for coming and finding your way here. We'll be having more meetups over the rest of this year and into the future. So hopefully this is, if you run a meetup, let us know if it's something to do with AWS or something interesting in computing. We can talk about whether we can host it for you. So I'm going to start off this evening and talk about a little talk. This is a new talk, and I just finished writing it about half an hour ago, so we'll see how that goes. This is called Mapping Your Stack, and I'll get into what I'm talking about as I go through. Okay, everyone found chairs and places to stand. Sorry, we don't have many. Sorry? Point the speakers to the side. Yes, that would be good, so they're not pointing at me. And then we'll get less feedback, and you will be able to hear better. Is that working? All right. Oh, cool. All right. And if, I don't know, there's some tall chairs. People can find something to sit on. All right. So, technology. So as our technology evolves, our technology stack, you've got to discuss it, you've got to be able to justify what does that stack look like, how is it evolving over time, what are you going to do about it. So I'm going to start off with a few questions, talk through how the landscape's moving a bit, and at the end I'll kind of go through a little worked example, which is the thing I just finished. So, what problem are you trying to solve? I have a friend who goes around asking this in meetings, and usually until he gets thrown out of the meeting because he doesn't get good answers. So if the problem we're trying to solve, I'm trying to install Kubernetes, I'm trying to install something like that, that's not a good answer. The answer should be something like a user or business need, right? Whatever you're doing in IT, like tie it back to what problem you're trying to solve for the customer. So maybe you're trying to deliver features faster, you have an international launch coming up, you're trying to lower cost or improve quality of service in some way, right? Those are all good reasons to be looking at your technology stack and figuring out how you're going to evolve it, right? You shouldn't be installing, well, you could say, to make my resume look better, I want to play with this new tool that I heard about at a conference, but you know, that's being honest, but it may not actually get you the result you want. So let's see, so here's another good one. What does the user need? Liam Maxwell, who was for a long time the CTO at the UK government cabinet office, he's still working the UK government. He actually put it on the back of his iPhone case so he could just hold it up and wave it at people in meetings, because he just went around like, what problem are you trying to solve for the user? Like, what is the actual user need? And the user need is the starting point for your stack, right? There's a user need. And behind that user need, there's a value chain, things that support that user need that provide value to it. So an interesting question there, what is your time to value? If you change something in your value chain, if you try to change it, how long does it take for that piece of work to touch a customer? So if you think about, I'm updating my code, and I've written some code today, how soon is that code running on behalf of a customer? That's a time to value measure. And how is the value chain evolving over time? And have you heard of Simon Wardley? Have people heard of Simon Wardley? Okay, you will have heard of Simon Wardley by the end of this. So S. Wardley on Twitter, there's a whole bunch of stuff about ducks for some reason on his bio, but it doesn't really matter. Simon comes up with these things called Wardley maps. And a Wardley map is a value chain versus evolution. So it says you start with the user need at the top, you put in all the things that are supporting it, the most visible things at the top, and you go deeper and deeper and deeper, and at the bottom you have like data centers and electricity and buildings and things like that, and at the top you have a mobile app or an interface or something that is supporting a customer, and there's all the bits in between. The thing that Simon likes to point out is that you start off with something that is novel, that you had to create from scratch, that was hard to build. Like if you go back 10, 20 years ago, a data center was a custom thing that you'd build. And if you had a better data center than the people down the road, you had a better product because your data center was faster or had some new features in it. And you had the idea of building a data center is the genesis phase. And then you custom build one. And then you start buying products, which are like you go and buy a cage in a colo, and you sort of pre-build it with some standard racks, and that's more of a productized data center. And then it becomes a commodity and a utility, and then you just open an AWS account. And what's happened over the last decade, basically, is that the fastest way to create a state-of-the-art data center is now to open an AWS account. Right? It's got all the features that already worked, it's already at huge scale, it's already got all the network bandwidth, and you don't have to go and build infrastructure and wait for it. But so the innovation, now everybody has access to the same leading edge data center technology now, it's just called clouds. And so you have to build something on top of that. So the innovation moves up a level to, can I use these base technologies in a better way and build something more interesting on top? So you typically, you get something, you commoditize it, you build something new on top, and it's further up the value chain. So the innovation moves closer to the customer, and things that are lower in the value chain sediment out into and go to the bottom right. So new stuff top left, and old stuff heads to the bottom right. So this is his kind of overall diffusion value chain, and you see uncertain, chaotic. So basically on the left-hand side, you're doing full agile development. You don't know, it's Genesis. You've never built this before. No one's ever built this before. It's startup land, it's a brand new feature. You have to experiment, you're A/B testing, you're iterating incredibly rapidly, you're throwing ideas at the wall to see if they stick. So that's the left-hand side of this plot. The right-hand side, it's very important that you tune everything, and it's basically Six Sigma. It's like, let's get all the variation out, let's optimize all the cost out. We know this thing, it's an incredibly standardized interface. It's like electricity, where there's a lot of innovation going on behind the plug in the wall to generate power in more better ways, but it still comes out in the same, 50 hertz, whatever, 60 hertz, depending on where you are in the world. And whatever the voltage is, but it's standardized at least at country level, right? Until you have to charge cars, and then you have to invent new ways to deliver electricity. But anyway, the electricity analogy has some interesting sort of ways you can dig into it. So the idea here is you're visualizing it, and you're visualizing not just where you are, which is the current state of your technology stack, but how it's evolving over time. So the important thing about maps is that they show position and then they show movement. And if you can't show position and movement, it's not a map, right? That Simon, if you follow Simon on Twitter, he goes on and on and on about this. All right, so another question. Let's look at your Wardley map. Do you have one? Let's see if we can draw one for you. So we'll get to that a bit later, and I'll show you what that might look like. So this is what's actually going on in IT. This is the old world of IT. We used to have employees, and we could connect to them at work because they had PCs on their desk or terminals on their desk. We had factories and supply chain. We had sales channels where we shipped boxes to a shop and found out how many came back and asked them how many they'd sold. And we had marketing analytics where we put TV, ads on TV, and then asked people like Nielsen how many people watched the advert. Right? That's the old world of IT. In the new world of IT, we've got more connected to the customers. So now our employees are on mobile apps, and we can build apps for them. We can build a mobile environment which makes them more productive. We've got factories and supply chain where you're tracking everything in real time as it's being delivered and as it's being built. We have online sales and delivery. The things that we ship are no longer just shipped in boxes, and then we never, if you hear from it again, it's a bug in the old world because it meant it broke. In the new world, you hear from it like once a minute until it stops working, right? That's the IoT, everything's connected. And marketing is now online. You need to know what people are saying on Twitter about your product or on Facebook and react in real time. So all of this means that the scope of IT has increased from scaling with the number of employees you have to the number of customers you have, and from the number of factories or sales outlets to the number of things you've shipped. And those are usually orders of magnitude bigger, so your scale of IT is now scaling with things that are in the millions instead of the thousands, typically. That is what's driving this digital disruption and the digital transformation across lots of businesses. If you think about it, if you go back to the time I was at Netflix, if you look at TV channels before Netflix, you put something on TV at 9 o'clock and you guess how many people watched it. I have no idea whether 9 o'clock was the right time on a Tuesday. Maybe everyone that would like it is doing something else on a Tuesday at 9 o'clock, so your program doesn't work. Netflix knows exactly who watched what when, and they can make a show and they can go find those people again. So there's a direct relationship with the customer, right? If you look at the ride-sharing apps like Uber or Lyft, they know exactly the customer, they know the reputation of the customer, the reputation of the driver, they can connect it all together. If you look at Airbnb, it's not just a face turning up at a hotel, it's a person with a reputation who you can actually personalize and market to directly, and you can connect them to the kind of host who will actually want to work with that person. So this idea that you now know a lot more means that you're really personalizing everything. So new needs, new things you have to build, personalization, really deep customer analysis, new channels that go direct to those customers, and a lot more things, a lot more scale, and much more rapid change. So this is the new world. And this is a Gartner quote. Through 2021, 75% of digital leaders will dominate a disruptive market segment that did not exist prior to their ascendance. So we're creating new markets as well. So AWS, what are we doing? I spend a lot of my time talking to customers like this as part of my new job. Unblocking innovation for digital transformation with these enterprise customers. Here's a few customers. The logos have got so small, just a few of them. We can't fit them on the slide anymore. We have pretty much anybody. But here's a few where they have actually been going through that digital transformation. GE's CEO once said that you go to sleep one night as a manufacturing company and you wake up the next morning as a software and information company. All right, Capital One is on the process of, they want to be a technology company monetizing in finance. All right, they are innovating incredibly fast for a bank. Ticketmaster used to be a place where you bought tickets. Now it's an API for serving ticketing websites. A lot of Ticketmaster's competitors now back-end into Ticketmaster. They've become the platform underneath. So this is some of the reinvention that's going on in this space. All right, so what does this pathway look like? First thing you do is optimize for speed. You want to get something done quickly, moving to cloud, getting to microservices, just like how fast can I build this thing? The next thing is you start to get to scale, and this is where you get larger numbers of machines. You've got to start worrying about how you've architected it. And finally, it gets more strategic. This is where you're shutting down whole data centers. So with speed, time to value is what you're optimizing for. In scale, it's distributed and it's optimized capacity. Right? You've got scale, the cost starts to matter, not just speed. And then finally, critical workloads for data center replacement. When you shut down all your data centers, you start uncovering that mainframe that runs the core business backend for your bank or whatever. You have to figure out how to move that. I'm working with some of the teams that are doing core banking applications, and over this year we're working out what is the right architecture for doing these highly critical applications on a cloud environment. So that's a really interesting area that we're looking at nowadays. All right, so we look at time to value. What is the time to value difference? And it turns out the fast companies are 440 times faster than the slow companies. It's not just a little bit faster, right? So how do we know that? Well, it's known as the Puppet and Chef DevOps. There's a report that's generated about DevOps that goes around every year. They've been surveying it. Nicole Forsgren is the key statistics research person who does the stats behind this. This is very, very detailed, statistically valid report. And this is a quote. They found compared to low performers, high performers have 46 times more frequent code deployments, 440 times faster lead time from commit to deploy, and 170 times faster mean time to recover from downtime, and 5 times lower change failure rate. All right. So what this really means is stuff that used to take months takes hours. Like you check in some code and months later it turns up in a product, to now it takes hours to turn up into the product. So that's really cool. That book just shipped last week. They had the launch party on Tuesday, I think. So the physical book is now out. You should go get it. It's going to be one of those books that everyone looks back to from this year. It's a really, really interesting book. All right, so if we look at this middle one, if we're trying to get this distributed optimized capacity, it's highly scaled. You're doing distributed availability. You're doing cost optimization and doing very high utilization. Most data centers and most applications that are in a fixed configuration are incredibly low utilization. If you're lucky, you're 10% busy. And if you actually look at the machine, you sign 5% of that are the security daemons and all the other stuff. There's just a few percent of real work going on, and most of the other stuff is all of the random junk that's happening on a machine. And this is a cloud-native architecture problem. So let's look at cloud-native architecture. This is a data center native architecture, and I said that I have some people do my slides, and I said, make a forklift truck go into a data center, make it look old. You've got spiders and things. But when you go to the cloud, there it is. It's lovely. Right. This is, I don't know how to do this in PowerPoint, but I found somebody that did. I will give out the name if you ask me nicely. So the difference here is instead of paying up front, depreciating over 3 years, you're paying a month after you use it for the number of seconds you actually used. That's the new model. We've moved from hours to seconds last year. So basically, it's by the second, and if you can stop using it for a few seconds, you stop paying for it. And this is radically different to having a data center full of hardware that's just going to sit there whether you use it or not. So there's the principle. Pay for what you used last month, not what you guess you'll need next year. And then how do you get stuff done? In the old world, you file tickets and wait, and you file tickets and wait, and eventually something happens if people aren't on holiday or went out to lunch or something. But the new world, it's API-driven. You make a call, it happens. Yeah, give me a machine, okay. Rather than give me a machine, sorry, he's out at lunch, and you got to wait till tomorrow or whatever. You're in the queue. So instead of deploying by filing a ticket and waiting, you deploy by making an API call at self-service. So this move to self-service across everything, and the more tickets you get out of your deployment, the faster. That's most of the difference between the 440 times is that all the tickets that went away. It takes an hour or two to automate delivery rather than meetings and waiting for the next week for that meeting so that you can discuss it and all that kind of stuff. So self-service, API-driven, automated, and move from request tickets at every step. You still need a ticket to track what happens, but it's a tracking ticket. You might need an approval step if it's a really critical thing, but basically you're just adding to the ticket with your automation to say, okay, this piece of code is walking out into the world, and this is the current state it's got to. Another principle. You just look at the drop down. I forget, we've got 18 regions now, I think. We've got another 4 that we've announced that we haven't even launched yet. Instant globally distributed deployments and data by default. Right? The normal case now is you can deploy your code anywhere in the world without even having to think about it. And used to be that you'd have to think, well, I need to hire a team in Europe, and I need to hire a team in Asia, and they've got to go find a building, and there's a whole lot of work, right? And then elasticity. In the data center, it's hard to get high utilization, and you keep running out of capacity when it actually does hit a peak. In the cloud gets bigger or smaller as you go, and you should be targeting many times higher. So if your data center utilization is 10%, try to target 40 to 50% in the cloud as the average across all time. Anytime machine gets idle, shut it down. And building that into your architecture is how you build a cloud-native architecture. If your application can grow and shrink with the load, that's a cloud-native architecture application. If it's fixed size and it can't shrink or can't be redeployed on a different sized instance, then you've got you're running a data center sort of architecture. So for relatively heavy predictable loads or stateful loads, you want to run containers or consistent instances and auto-scale them up and down the number that you have. And for spiky loads that come and go, you want to be using serverless, AWS Lambda, to just have the machine there when it needs to be there, and it goes away in between. And if you need 1,000 machines, one point, it'll make 1,000 of them, and then they'll be gone immediately. So there's a huge concurrency with very little cost. Everything's always 100% busy, and this is one of the things that drives utilization up. So here's another principle. turn it off when it's idle, many times higher utilization. So if you think you need 5,000 machines in the cloud, in a data center, the average number of machines in the cloud should be maybe 1,000 machines, right? Because that's the difference between 10% utilization and 50% utilization, right? The average. I mean, you might actually at some point have 10,000 machines in the cloud, and other times you have 300, right? At the weekend or something when nobody's looking at your application. Another principle, immutable code. So you automate your builds, you break a container, you bake an AMI or AMI, you automate it, you have ephemeral instances, use containers and functions, blue-green deployments, and you version everything. All your services are versioned. Your data routing in production is routed by the version. So if you need version 2 of something, it's sitting there. If you need version 3, it's sitting next to it, and your traffic goes and finds the new version. And then you can have multiple versions at once, and you can gradually retire the old ones. So here's that set of principles. Pay as you go afterwards, self-service, no waiting, globally distributed by default, cross-zone and region availability models, high utilization, turning idle things off, and immutable code deployments. Okay? So we put those into practice. I'm going to pull up a specific sample. I'm going to talk about travel search. Let's go back. What problem are we trying to solve? Users want faster, more personalized search. Business wants faster feature releases and lower costs, right? So we'll pull that in and say, what are we going to do to our architecture to get that? And what does the value chain look like? So there's the user need. There's a search interface. There's some kind of travel data store. And behind that, there's some compute and storage that it's running on. Okay, this is a very simple version of that. So there's a place, wardleymaps.com. You can go visit it. There's a free sign up, and you can go and create your own Wardley maps. So I actually went and built some. This is the bit I did this afternoon. I'm not sure if you can read this, but this is the starting point. So Simon Wardley himself hates flying because he's always uncomfortable in coach. He always gets backache, and it puts him out. So he hates flying coach, but the top of this connects to, his user need is he needs to find flight options, and he's trying to get from London to New York or something. He's got a mobile search app, which is custom built. That runs on, it's talking to Nginx, which is an API service, which is a product, so it's a bit to the right. Then there's a search travel service, which you built, and there's a search cache for catching all the recent searches, so make it more efficient. And that's running in a travel search data center. That's all custom built, so that's all this stuff in the middle. I have a laser. Yeah, that's this section. And over here, the search travel service looks up for a global distribution system. This is like Sabre or Amadeus. They're called GDSs. And they're running in their own data center, which is a bit more productized because they're a SaaS provider, and they can set up in multiple places, but they're running it somewhere in a data center that you're subscribing to. Right? So the first thing we're going to do is ask Simon what he wants, and he wants a comfy seat. So he wants to do search for flights that only have comfy seats. So if you tried searching for flights, everyone does flight search, right? Try searching for flights and you want to have a 787 Dreamliner or an A380 as the only options, right? Where you can hunt through the guts of the results and maybe try to find that option, but it's not actually an option in regular flight search. So we're going to add that option for Simon so that he can get a comfy seat, and he has one extra option in his mobile app that says, I want comfy. And then in the back end, we now have to cache all the details and rummage around in it to find only the good planes, right? And that are flying to New York with the comfy seats, all right? Now we're caching a lot more data, and the thing's costing more, and it's running, and he's complaining that it's taking too long to do the searches, and it's costing us too much to do the searches. So let's take this stack and let's modify it a bit. So what we'll do is we'll move Nginx to API Gateway. We'll take the travel search and we'll rewrite it using AWS Lambda. And we'll take the search cache, which is a custom thing, and we'll run it on Redis on Elasticache. So all of those things move to the right over here, which is cloud, basically. Pretty much all the AWS services live over here in commodity utility, right? So when we do that, we are no longer running in our custom-built data center right? So we've exited the data center, and now we have this. So here's Simon, he's got his comfy options, mobile search app, goes over to the API gateway. Here's the travel search function instead of service. That runs on Lambda, and it's got a search cache, and then if it's not in the cache, it looks up in the GDS, which hasn't changed, right? So this is a bit faster, it's a bit cheaper to run, but we can optimize it a bit better. So the next thing we're going to do is optimize the GDS. And the GDS can be deployed anywhere. So we go to our GDS provider and say, do you have this running on an AWS cloud anywhere? Or could you? And they say, sure, we can fire up a copy, or we've got a copy running in Oregon, let's say. Okay, so let's migrate all of our Lambda functions and all this stuff, our entire application, to be in the same region as the GDS is running, right? So then we go here. Now, our SaaS provider, which is a totally different business, is running in the same region as our application, which means it's less than a millisecond away on the network with ridiculous amounts of bandwidth, many terabits of bandwidth if we needed to between us. Minimum possible latency, we get even faster searches, and there's lower cost, lower latency for everything, right? So we've optimized for speed, we've optimized for cost, and what I've done here is walk you through, like I had a fairly simple stack here. You could think, how do you what does your stack look like for one of your applications, and what is your most interesting workload? Like for Netflix, this would be play a movie. What's all of the workload that's in there, and what state of evolution is it at? And can it migrate to the right as you go through? So that's what I mean by mapping your stack. We can use this to sort of talk about workloads. Now, I'm not really saying how this code works. I'm just saying, what are the technology choices you made, right? And if you look over here, you custom wrote the thing and it's never been written before, right? Brand new thing, no one has ever new algorithm. Some brand new AI algorithm that does something that no one's ever done before. The next phase over, custom built, means, yeah, we knew what it was supposed to do, but we custom wrote the code to do it, okay? Over here, it's a product. You bought the thing. You bought Nginx because it knows how to do API gateway stuff. Or you bought a product, you downloaded an open source project, something like that. And over at the right, you're buying it as a service on a as you use it basis. So you can map across that and you can see where should my app workload, where should I be investing my time to build custom things, and what can I push off to the right. So that was the idea I wanted to talk through. Wrap up now. How much time do I got? Could take a few questions if you like. It looks like I've got a few more minutes to go. So
in this approach, you are mostly using Lambda through API gateway. So if thousands Lambda are there, how do you manage those?
I'm sorry, what was that?
So suppose you gave example of we are giving thousands of Lambda exposing to API gateway. So how do you manage those many number of Lambda in AWS?
So, okay, so the question is about how do you manage large numbers of Lambda functions on AWS. There's quite a few large-scale applications that have been built on Lambda right now, so there's quite a lot of tooling emerging around it. I'd say that it's becoming fairly mature. We have the serverless application model, SAM, which lets you set up all of the configuration you want around it. If you're trying to monitor and track it, there's a tracing service called X-Ray that AWS has, and you can use it for doing sort of APM-like tracing through any application. But when you use it for Lambda, it measures the events going into Lambda, and it tells you how long it took before the Lambda function started and how long it ran on individual calls. So you can get a trace of an individual request going through your system and track those, and it stores them for some period of time, right?
Can you track what is the input coming in Lambda and what is output?
Yeah, I mean, it doesn't log all of the data, but it logs enough that you can tell. You can tell it basically, I want to store, say, a customer ID or something, so you can track what's going on. This sort of trace annotation is becoming a fairly common thing, right? There's several different frameworks for doing tracing, so we have our built-in one because in order to monitor Lambda, we have to go inside Lambda and monitor it, so we have to build our own one for doing that. There's an API, and if you're a trace vendor, you can pull data out of it and merge it with your other trace data. But there's lots of ways of doing tracing. There's some work going on right now to standardize trace formats, and the trace vendors get together every few months for a little meeting and try to not build randomly different things, but actually build things that would interoperate better. So much going on there. The book's called Accelerate. It's from IT Revolution. It's Gene Kim. If you know Gene Kim, he wrote the Phoenix Project and all those things. So he's one of the authors on it. Nicole Forsgren and Jez Humble, who wrote Continuous Delivery book. Nicole and Jez run a consulting company called DORA, DevOps Research Association. So there, you can, if you want to, you can hire them to come in and do an assessment of how well you're doing at your DevOps. And they'll give you lots of, they benchmark across all the different companies. So that's a really interesting book just that's coming out this year. There's a few good books coming out this year. The other one, Release It, which by Michael Nygaard, version 2 of that, second edition of that just came out as well. So that's another good book to look at in this space. Yeah. There's somebody, yeah.
So you're describing optimizing pushing to the right. Are there any guidelines for when that becomes technical at all, or when it's more worth it to not do that? Is that ever the case?
Sure. So the question was, optimizing by pushing to the right, is there times where you want to go to the left? Sure. If you can build a better version of something that's in the stack, then it's worth going to the left. Let's just look at electric power. Electric power is commoditized and whatever. When electric cars come out, you find, well, you can plug it into a dryer outlet 40 amp thing, but it's not really designed to have cars plugged in it. And it doesn't work if it's outside in the rain. So Tesla came up and made their own plug, right? So they went to the left. It's a full custom design. You have to be a Tesla to plug into it. But they've deployed it widely enough that, they've got their own proprietary charging network that just works for Teslas. And then there are other charging networks for other types of cars, but they're using it now as a barrier to entry in the market, but other people are trying to get enough volume, So there's a little war going on in high current charging networks, but that's something where they took something that was well commoditized and said, well, we have a new requirement that's got to work in the rain, so we have to go out and do it, innovate to the left, right? So if you can, sometimes it's worth doing that. You might find in your data center environment that you want to have a particular type of hardware like GPUs or FPGAs, although we have those on AWS now. So you can do more and more custom things on AWS. But in the past, there may be very specific types of hardware that you wanted that you would build a very custom data center for. But generic data centers are getting much more boring as a thing to go build. It's very hard to differentiate now.
For those companies that you mentioned, 440x and more efficient, how does this translate into cost versus the conventional?
Yeah. So the question is, how does it translate into cost when you're going much more efficiently, the 440x times? So what actually happens when you speed, so if you have a release that's going to take months, then you have to have a project manager to manage the fact that it's going to take months. When you have a release that takes an hour, you don't need a project manager. So there's a layer of management and people that actually disappear in this process. And actually one of the problems in IT is that there's a lot of unemployed project managers looking for work, and you have to figure out how to retrain them or whatever, because the makeup of an IT department that's working in the fast way is that there are a very small number of project managers, and when you're running these long waterfall projects, you're overrun with project managers, and they keep making you go to meetings and write reports and stuff like this, which is not actually productive. So what you get is much more productive output, fewer meetings to go to, stuff happens quicker, and it happens in less engineer time. So you tend to reduce costs as a side effect of going faster. And what I've also seen is if you try to optimize for cost, quite often you slow things down and it ends up overrunning and costing more. You end up going so slowly that it ends up costing you more. So it's very hard to get low costs by trying to get low costs. If you optimize for speed, you get low cost as a side effect, just because everything's more efficient. But a lot of this is pushing the decision making down to a low level in the organization And the microservices architecture means that it's very much local decision, right? I own this piece, this service that does one thing, and I own it, and I can change it whenever I want to, and I have to go and argue with the entire rest of the company because I'm about to update a monolith that I might break, right? So that's part of the reason for microservices was to get speed by breaking things into small chunks, and you get lower cost of deployment there. There's some inefficiencies because you're crossing machine boundaries and things, so that's the sort of other side of it. But generally speaking, there's a lot more emphasis on people time being the main cost and getting things out being the thing that matters. You can usually take a little bit of inefficiency in the way it's deployed. Yeah. A question? Let's see what the timing's going. We got just one more question then. Yeah?
Can you open source the Simon's algorithm so I can make it into a product?
Simon Wardley's thing?
Yeah, the algorithm for travel, for finding travels. Can you open source it so I can make it into a product?
What do you want to be open sourced? For the example? I'll put the slides up, but I mean, it's there's a JSON object that restores the output of the Simon Wardley map. It's basically a SaaS service with a little drawing tool. That's all it is, right? And you sit and poke at it. The guy that built it eventually got a job working for Simon's company to do it full time. He was doing it part time. So it's moving from being a hobby to being something that's a little bit better now. But it's not too hard. I mean, I use it every few months, and it usually changes enough in between that I have to relearn how to use it. But it's not hard to use. You just drag things around and connect dots. And the trick is that to create the sequence, you do a basic drawing, and then there's a little button you click that clones it into a new one, and then you modify that one, and then you clone that one into another one. So you create this series of clone diagrams, and it dumps out little PNGs that draw the thing. But you know, it's pretty straightforward. I'm happy to share my diagrams if you want to, but this took, I spent about an hour making those this afternoon. It's not that hard. The hardest thing is thinking through what you want to do. The tool, you can do it on a whiteboard or using Visio or whatever you feel like. Anything that can draw little diagrams is fine. Okay, but maybe one more and then we'll move on to the next talk.
Who actually created this awesome presentation?
The awesome presentation slides, I used to have this on my deck. There's a company called Silver Fox in Seattle, Silver Fox Productions. And they make really, the way I do these presentations now is I get an iPad and Apple Pen, Apple Pencil, and an app called 53 paper, and I scribble. Because if you do it in PowerPoint, you end up with bullet points. And to avoid doing bullet points, I scribble pictures and I write what I want it to look like. And then I send this scribbles to them and they send back beautiful presentations. But I have priority. Tell them I sent you, but I'm referring business to them. But if I say, can you do something for me in a couple of days, they jump there. I get priority, right? But anyway, it's I don't know, a few $1,000s to get something done. So you're gonna have a little bit of budget, but I'm using this reusing these decks quite a lot, and I got fed up with my horrible scratchings because I'm a terrible graphic artist. So this has been fun. Okay. All right, we should move on to the next talk. And thanks everyone for coming by.